Thanks, Horatio, for the nice introduction. We are going to talk about expanding the exam testing landscape with virtual ECUs today. So I'm Robert, and my colleague Katerina will have the second part of the presentation today. So my background is more on the virtualization, on virtual ECUs by themselves, and Ekaterina's background is more on the exam testing side, so she will show the more practical approach to this. But we will start with the general concepts and a little bit of introduction on what we actually understand by this topic of virtual ECUs. So we will also dive into the virtual ECU levels on several sides of the virtual ECUs. Basically due to the fact that virtualization by a word is used in so many different conditions and in so many different topics, so that we would definitely like to show what we understand by virtualization of ECUs, which we then call virtual ECUs. We will also, of course, show some use case examples, and then take a little bit deeper dive into the Zilla API and connection to exam and some specifics about using virtual ECUs there, followed by a second approach to this, and also show a conclusion in the end. So we are completely aware that there are several virtual ECUs already present in several companies, and even in the same company, like for the Volkswagen Group. And we are always interested in finding more use cases and getting more different use cases together to in the end get the best result of using this technology by itself. So where do we come from? At first, of course, there's an idea, and this innovative product, of course, must kind of include some ECU, but it might be a steering, it might be some battery management SoC, and of course you've got the best team and everybody's passionate about this idea, and in general you've got the management convinced about your idea, about the plan, about money, but you are facing some specific challenges. So what might happen is that management has cut your prototype number by probably 50%, or your system on chip cannot be delivered in time. So you're facing time challenges here. What also might happen, of course, is that new norms require you to include simulations in your testing, which might happen, for example, in SLC or SLD ECU environments. And one idea here is to establish virtual ECUs for development processes and additionally for the testing processes. And not just by the end of the project, but probably even by the beginning of the project to get a holistic approach onto this whole topic. So let's start with the first side of what we understand by this virtualization, by this virtual ECU approach, and this is the hardware. In general, the device under test that we have in focus here from testing is usually the ECU software, and this ECU software that runs on some real hardware. It's a physical hardware controller, might look however, but the architecture is definitely not what you usually have in your PC architecture. So it might be some Infineon Oryx, it might be some Renesas processor. It's something completely different from architectural side, and usually it looks like you've got some development boards, some ABC samples, or different setups, including hardware and loop simulators. And of course, you're limited by physics and the real world. So it's a real device. So there's the limit of your development and testing approaches. And also, if you would like to change physical setups, you need to get to the hardware and really change the wiring or something. On the other hand, what we have is the virtual ECU, and there are quite a lot of different understandings and words for this. So I think the most classic might be the software in loop approach. More newer, biggest approach might be the digital twin, or a little bit less might be digital shadow, but I'll refer to this whole concept as virtual ECU inside the talk. What is it? It's basically a software-based representation or a simulation of the real ECU, and therefore the real ECU software that is our device under test. So the main point is it's entirely software-based, and so we've got the software tools running the simulation or running this ECU software, and they are running on a PC server or any cloud environment there. The limits are, of course, it's constrained by the simulation models that are included in our simulation. And the benefits are, of course, that it's easy to clone this, to modify the system under test, and to even run different configurations like you have for variant management usually. So that's the first side. Second side is usually the formal side. So when talking about virtual ECUs, they are typically referred to as different levels. So this has nothing to do with autonomous driving inside here, but I would like to point out one very important difference that you have here. So level 0, of course, lowest 0 sounds like the most simple thing. We've got an algorithm model. It's running inside some MATLAB Simulink environment, for example. So this is usually somehow interpreted code, has less to do with the real ECU code that we will be seeing later in our product development. Then we've got the higher levels, which are usually like level 1 to 3. And I'll come to a little bit more differences inside these levels later. But the main point is here that this is host compiled code. So it's directly running your ECU code, which is our device under test, directly running this on the PC hardware. And to create a construct like this, you need to actually have a high level of application and of software knowledge, because it includes modifying the software to be able to run on your PC hardware due to the different architectures. The highest levels, including the physical ECUs, usually we are running target compiled code. So the same code like you would use to run on your ECU is now running inside the simulation on your PC. And like I said, the ECU code is not modified anymore, but we need to have a high level of hardware knowledge to create this type of setup so that the software runs correctly inside your environment. So this is the most important differences between our levels, and that you will need to get to the strategic side. So to be able to benefit from this, you have to integrate this into your test strategy somehow. And usually in the typical V model approach, where the hardware and loop simulator is top right somewhere, we see the software and loop, the virtual ECU. We see it more on the software integration and testing and software component testing. It might even go to network testing, where we've got several ECUs interconnected in some CAN FlexRay network, where we really want to check what's happening in the communication between those specific ECUs. And there comes, of course, the point. So the virtual ECU level that you will later apply highly, of course, depends on the use case and on what you've got at hand. What's the test focus of your whole setup? So that's for the medium flying level of the presentation for now. So let's get a little bit more into the details and concepts that we have here. So we had the basic control model, which focuses on algorithms, for example, and we also know this from hardware and loop simulator context, because this is what we usually refer to as a simulation model. So those are usually also integrated in hardware and loop environments and are run alongside the hardware and loop simulators like the ResBus simulation and so on. Getting a little bit higher on the virtual ECU ladder is actually levels 1, 2, 3. And those are typically aligned to AUTOSAR classic specific software. So on level 1, we usually have got only application layer software testing. On level 2, we include more and more of the middleware, and therefore also need a simulated basic software there. And when we get to the higher level, we've got production-ready software, but are still missing some hardware drivers. And this approach generally needs the software to be modified. So we take the production code here, but need to modify this for generating such a virtual ECU. And the setup that we might create out of this typically looks like this. We have got a software product running the simulation of this virtual ECU, which might be Synopsys Silver for the level 1 to 3, where we have a virtual ECU running alongside other virtual ECUs or models. We control this from the exam side. We might also employ some calibration tool here. And this setup we will also show a little bit later in the presentation. General advantages of this setup is that we definitely have early bug detection. We can employ this setup in the development or even testing process. We can create quality gates testing the software before we are even moving to the hardware and loop simulator. And therefore, we integrate the software and loop test bench as an additional test bench into our testing process, like previously mentioned. And one typical advantage that we want to achieve here is that we want to use the same test cases for hardware and loop simulation and software and loop simulation, so that we get an advantage there by not having to implement the same test case over and over again. Coming to the highest level of the virtual ECU, we what we usually call level 4A or 4B. Where we typically simulate an entire ECU. So we definitely have a processor simulation model, and the ECU software, which is still our device under test, is running inside the simulation. Additionally, of course, for the software to function correctly, we need peripheral models for in hardware for the ADC, for example, for communication, like CAN or FlexRay. And this even higher level of virtual ECU integration allows us to do even further testing or have a little bit different test focus, because we can also focus on functional safety requirements and on security testing, and for example also employ destructive tests that would not be possible on our hardware and loop simulator without actually bricking the ECU that we want to test. When we think about security features like fuses that are generated in hardware. So coming a little bit nearer to the exam approach. So now that we have got a general understanding of the virtual ECU by itself, by the concept and what we understand from this, I would like to point out some points that we think are necessary and important inside this setup. So, of course, we need an environment where we execute our either processor model or where we execute.
Robert, ich glaube, deine Verbindung ist.
Yeah. Okay. Yeah. Then, yeah, I will try to continue the presentation. Or Robert, you're here again?
Yes, I'm here again.
Yeah, great.
Yeah, sorry, now I'm connected via hotspot. I'm even in the office today. So everybody can see me and also the presentation, I guess.
Yes, works
okay,
again.
Thanks. Okay, so now that we want to connect to our test automation system, we need to execute our simulated ECU, our virtual ECU, and one very important aspect that we talked about today is controlling time. So we now not only have a system running in real time, but we might have a system running slower than real time, or a system that might be even running faster than real time, which highly depends on what type of virtual ECU we are running, what we are able to achieve with regards to time. Additionally, of course, we want to do the typical things that we also would in hardware and loop simulation. We've got some bus communication going on from CAN or FlexRay. We want to control the hardware, like for GPIOs. We want to control the software like we would with XCP or even with a hardware debugger. But now that we have a model or a simulation of our hardware, it's even possible to get a even more direct approach here and directly control the software. We can write any software memory that is accessible to the simulation, We might even skip the XCP part here. Last point, we also, of course, like shown in the smaller example, we want to do parameterization by using Canopy or Inca tools, for example. And also here, we usually want to use what's available on the real test bench. We don't want to develop everything over and over again, but we want to reuse our existing tools. And the last point on the list is actually that we want to trace the signals and store them in a standardized format, like the MDF format, to be able to later evaluate our test cases that have been running inside our virtual ECU. So now that we've outlined the concept and the specifics for this virtual ECU approach, I would like to hand over to my colleague Ekaterina, who will take a little bit more deep dive into showcasing one of the use cases that I've presented.
Thank you, Robert, for the great introduction to the virtual ECU topics and its levels. Now let me demonstrate our example where we connect exam with the Silver software, and in the Silver software we actually run a gearbox software model. It's a virtual ECU level 1 model, and in order to demonstrate that connection, let me start such a simple test case. First, we start our car model, then we try to accelerate it to 40 kilometers per hour in some restricted period of time, and then check if it actually reaches that speed, and then we just stop our simulation. So let me start the test suite. And here we will choose the correct system configuration. And I will now squeeze that screen a little bit so you can also observe the Silver software, how it looks like. So now the connection is establishing, and in a couple of seconds you will see the Silver. And once the connection is established, our test case will start there, and we can see what's going on there. So that's how the Silver software, Silver gearbox model looks like. Now the test is starting. Our car model is trying to accelerate to 40 kilometers per hour, and then the model is just stopping. So once it's finished, we can check in exam if actually our model reached the speed we wanted. So let's check it. Yes, the test was successful. Our car model reached this 40 kilometers per hour speed. And to say, and what's so special about it? So it's the same test case. We can also run it on a real ECU, and you're right. Actually, it's the same test case. You can run it not only in virtual ECUs but on real ECUs. All you need is just to choose the correct system configuration. Great. But how do we actually establish a connection between virtual ECUs of this Silver software and our exam? And the answer is simple. We do it through XIL API. And on this slide, you can see an image that depicts the idea of XIL API. And the idea is quite simple. We would like to distinguish between the test automation and test bench. And it's done through mapping that you can see in between. So just a moment. And yeah. And our connection between exam and Silver software is done through m-apport that you can observe here. And through m-apport, we can read and write variables. But what if, for example, you need to make some complex operations like calibration and mapping? For it, there is this ECUC and ECU imports available. It's XIL API version 2. But both of these ports were combined into one ECU port in the new search release of XIL API, but we are going to speak about it later. Right now, all I wanted is just to emphasize how great it is to use XIL API in order to create connection between two different tools. Well, first of all, your test case can be used across various platforms. It doesn't matter which vendor of software or hardware you have. For example, I've showed you that we have created connection between exam from Micronova and Silver from Synopsys without any problems. And it brings actually some benefits, like you do not need to be depend on some specific vendor that provides you hardware and software, you can now choose. And by that, you can save your costs, definitely, which is quite important right now. The last but not least is that once you learn XIL API, you do not need to learn any other APIs. You are great. You can connect any tools that supports XIL API and free to choose whatever software you want. So great. Having all these benefits in head, we can actually go back and see what was going on actually in the test case I showed on the background. And on the background, we have a test case in our exam test automation. And before we can run it, we definitely need to create a connection with MA port. It's done thanks to the config XML file provided from a Silver model to which we want to have a connection. Then we definitely need to have a mapping in order to read and write variables available in Silver virtual ECU model. And once we are good with it, we can actually start our virtual ECU model and proceed with any tests we want. Okay, it was for MA port, but again, for some complex operations, some calibration and mapping in the XIL second version, there is ECUC and ECU imports, you can see here. However, I've already said that both of them will combine it into one ECU port. And on this slide, you can just observe two different versions, the second and the third version, and what are the main differences. Well, the logic is still the same. We still have mapping in between our test automation and test benches. And the news is just there is this ECU port instead, ECUC and ECU import, and a service-oriented communication port that was added. And previously, when we speak about XIL second version, ECUC and ECU import were not supported so actively, probably because everyone was waiting for the new release of XIL API. And I personally believe that in the future, we'll definitely have more implementations, not only with the main ports we have like EMA, ES port, but also with ECU port and maybe SOC port. And if to speak about other changes that we have in the XIL API third version, is that now the XIL could be also supported in Linux platforms. There are more advanced data structures, and since there is service-oriented communication ports introduced, we definitely need to have a concept for streaming and event handling that's also introduced in this XIL third version. Okay, great. Now we know that it's also possible to create other ports connections and make more complex operations. But what if, for example, let's consider another situation when we have our model, the one that I've presented to you, running in Silver software, and we have also two other models running in NovaCard software, and we want to connect all these models together, and we want them to communicate together and work. And what could we do in such situation? We want our Silver model to be moved to the NovaCard model. For the situation, there is functional mockup interface. It's a free standard that describes a functional mockup unit, and this functional mockup unit is just a container for your model. And this model could be any from 1 to 3 virtual ECU models. And once, if your tool supports this functional mockup unit or this FMI interface, you are happy. You can just create this FMU and transfer it from one platform to another. And what is FMU? FMU, it's just a zip file. It's a container that inside has some model description XML. It definitely has some binaries for one or multiple platforms, and it could be also a black box and source code, mainly in C. So inside FMU, it could be MATLAB model, Silver model, whatever you want. And if your tool supports, like our NovaCard, for example, FMU, then you can just transfer this model between these various tools without any problems. And here, just example how simple you can do it. If you have Silver software, there you have virtual ECU. For example, the one I have showed you. from this virtual ECU, we can create an FMU, and with the help with FMI, and then this FMU of virtual ECU model will contain the C code, libraries, model description, XML as a basic. And then thanks to some software, for example, Micronova has the Escape FMU, you can transfer your model to any platforms. And for example, from this FMU, we can transfer it to our NovaCards friendly software packages, and we are great to go. We can just start the same model in a different platform. So we still have exam, we still have XIL API, we still have the same tests and same model. Everything is great. All we need to do is just to change system configuration in exam. Sounds simple, right? As a conclusion, I would like to present just a short overview of what we have discussed. Robert gives you a great information about the virtualization approaches and how great it is, especially at the early stages of the testing, how it can save you time and money. And then I've showed you some example of connecting exam with some virtual ECU models running in Silver. There was also a couple of words regarding new XIL API standards and how it can also help in the testing. So I hope that our presentation actually shed some light on virtual ECU topics and its groundbreaking benefits in testing. So I personally believe that together with XIL API and FMU, virtual ECU will be just the next step in ubiquitous testing. So thank you for your attention. And yeah, if you have any questions, we will be very, very happy to answer to them.